Do you know that right now, at this moment, every object, you, me, calculator, pen, even the far, far, far away galaxies are pulling on each other? Basically, gravity is everywhere and we just can't escape from it. So this has something to do with the topic that I am going to discuss in this video. Before I begin with the topic that I'm going to discuss in this video, I would strongly suggest you to download the PDF file, right, regarding this topic, which is called gravitational field. The link has already been attached in the description, so feel free to download the PDF file. It is free, of course. This gravitational field is quite important in your A-level physics, whether you are talking about the CIE board, EDEXCEL board, or AQA board. So not just guiding you on gravitational field, the concept of gravitational field, but I'm also going to guide you on how to answer some topical past year questions related to gravitational field based on the CIE paper, EDEXCEL paper, and AQA paper. So please stay tuned until the end of the video. Now let us begin with gravitational field. First of all, the definition of gravitational field is definitely very important. So what is the definition of gravitational field? Let me give you this, right? Feel free to copy down this and feel free to pause the video if you think that, okay, you still need time to copy this. So gravitational field itself means a region in which a mass experiences gravitational force, because it is, after all, it is about gravity, gravitational force when placed in the region. This is a definition of gravitational field. Now, let me highlight the keywords for you. A region. If you don't like the word a region, you can actually replace it with a space, right? A space in which a mass experiences gravitational force when you place that mass into the region, right? In the region of the gravitational field. So I want you to bear in mind is that every object, right, as long as they have mass, as long as the object has mass, for example, sun has mass. So sun has gravitational field around it. And gravitational field is about attractive only. Gravity is just attractive. It would not repel. So whenever you draw gravitational field lines, gravitational field strength, vs gravitational field lines, there is a close connection between gravitational field strength and gravitational field line. I will give you one example. Let's say this is a mass, a big mass. I'm going to write it down. This is a mass. Since this is a massive mass, even valid to small mass, it is just that it is not so obvious. Since this is a big mass, there is gravitational field lines around the mass. And this mass is called a sphere mass or a point mass. So the gravitational field lines will be quite radial, outwards. Right? So when you draw the gravitational field lines, remember, no field lines can cross each other. Remember, you see, they must be, okay, put with a certain distances between them. And don't just draw the gravitational field line, because gravitational field line is a vector quantity. Gravity is about attractive. Therefore, when you draw, make sure that arrow must be inwards to point into the mass. So any object that is close to the mass will be attracted towards the mass. Now, what to do with the gravitational field strength? Right, the closer the lines, the closer the gravitational field lines, the stronger gravitational field strength. If the further the field lines, the weaker the gravitational field line, the gravitational field strength. How do you see? Let me do some highlighting here. Could you see that gravitational field lines in the yellow region are closer as compared to the gravitational field line at the blue region, because at blue regions, how do you see? Gravitational field line seems to be more spread out. Distance between one field line to the other field line is larger as compared to the distance between the yellow region, the gravitational field lines in the yellow region. So that is how we see whether the gravitational field strength is larger or it is weaker. So the gravitational field strength in the blue region will be weaker. Why? Because the gravitational field lines are more spread out as compared to the gravitational field strength in the yellow region, because the gravitational field lines are closer. That is how we relate gravitational field strength and gravitational field line. Now, the next one. Okay, let me tell you the story. Right, it all started, the gravity, right? First discovered by our famous scientist, which is Sir Isaac Newton, right? It all started when the apple dropped to his head. Oh, that's how the gravity works. Because when the apple dropped to my head, it's like switch on the light bulb in my head, right? Let us discuss about Newton's law of gravitation. So Newton's law of gravitation, okay, I just put a picture here so that you can see this is the sun and this is the earth. Sun and earth are two masses, right? So they are further away from each other, not as close as the one that's shown in the picture, or else we'll all be melted. Don't you think so? Right, that is the distance between the sun and the earth. So Newton's law of gravitation states that gravitational force between the sun and the earth is directly proportional to the product of two masses. That will give you 1 mark, okay? And inversely proportional to the square of their distance. So how do you see the distance? Distance between the sun and the earth must be measured from the center of the earth all the way to the center of the sun. This is what we call distance between the sun and the earth in this case. Right. So feel free to pause the video if you still need time to copy down the facts. Mathematically, now let me prove mathematically. First of all, I need to redraw this. This is a distance joining from center of the earth to the center of the sun, which we call it as r. I'll put it r as symbol. R is not the radius. Remember, r is the distance measured from the center of one mass to the center of the other mass. This is a symbol of gravitational force that I'll be using. Fg represents gravitational force. Don't worry, I'm going to write it down later for you. It's directly proportional to the product of two masses. I put capital M and small m. It is because that sometimes the masses are not the same, right? It is not always the same, right? So to differentiate between one mass and the other mass, that is why I put capital M and the small little m here. But inversely proportional to the square of the distance, so distance square. Yeah, right, let me write it nicer here. Inversely proportional to 1 over r squared. R is not radius. I have to tell you again. R is the distance measured from the center of one mass to the center of the other mass. Right, to join them together, this relationship, Fg, gravitational force, is directly proportional to mm over r squared. To get rid of this symbol, proportionality symbol, right, Sir Isaac Newton actually put a constant, which he called it as G, capital G, over r squared. Now let me explain the meaning of all these symbols right here. Like, this is the equation of the Newton's law of gravitation. Fg represents gravitational force. Capital G represents universal gravitational gravitational constant, and the value is always constant at 6.67 times 10 to the power of negative 11 Newton meter square per kilogram square. Now, M represents M and M represents masses it involved. In order to feel the gravitational force, according to Sir Isaac Newton, the two masses must be facing each other in a straight line. So these two masses, okay, capital M represents a bigger mass, or it is of the same mass, then you just sub in the value of the mass. Any masses will do. Normally, capital M represents a bigger mass, but if the two masses are of the same value, same magnitude, just sub in the two values, right? Any of the masses, right? R represents, oh, I forgot to put R. R represents the distance between two masses. Must be measured from the center of one mass to the center of the other mass, square. Now, the graph, if you want to draw the graph of gravitational force, which is measured in Newton, against distance, which is normally measured in meter, right? The graph is, could you see that gravitational force is inversely proportional to distance square? And this is also called inverse square law. Inverse square law meaning to say that a physical quantity which is inversely proportional to distance square. Right, so you could start, okay? It is inversely proportional, so it's quite curvy. So this is a graph. Now, okay, let us not waste too much of your time. Let us straight with the passive question. How about that? So A, this is related to CIE A-level physics. What the code is 9702. Let me read the question. This is part A. The point P in Fig 1.1 represents a point mass. On Fig 1.1, draw lines, plural, to represent the gravitational field around P. So since P is the mass, gravitational field is always attractive. How do you draw? Okay, I'll give you a little bit of guidance. So you draw right and left. Make sure that the gravitational field lines that you are drawing is not touching each other. They are not touching each other. So it's a straight line that are not touching each other. And then, okay, 1 mark will be given to the pattern, and the second mark will be given to the arrows pointing inwards to show that the gravitational field is attractive. That's all. Now, another CIE question as well. Okay, it is about calculation. Let me read the question. The Earth may be considered to be a uniform sphere of radius 6.37 times 10 to the power of 3 kilometer. Be careful with the kilometer. One of the prefixes. With its mass of 5.98 times 10 to the power of 24 kilogram, concentrated at its center. So the Earth spins on its axis with a period of 24 hours. First part, a stone of mass 2.5 kilogram rests on the Earth's surface at the equator. First, calculate using Newton's law of gravitation the gravitational force on the stone. How many marks given? 2 marks. So you have to recall the equation. So the equation of Newton's law of gravitation states that gravitational force is equal to Gmm over r squared. Now, don't have to worry about the value of G because it will be given. The value of G is 6.67 times 10 to the power of negative 11. Mass, you see, there are two masses here. One is the Earth, mass of the Earth. The other one is the mass of the stone. Mass of the Earth is larger, so I respect the mass of the Earth. So I put it as 5.98 times 10 to the power 24. Small little mass represents the, small little m represents the mass of the stone, which is 2.5. Just put 2.5. Divided by the distance between Earth and the stone. And then I want you to see this. This is the Earth. This is a small little stone on the surface of the Earth. So the distance between the center of the stone to the center of the Earth actually is the radius of the Earth. Measure from the center to the center because the stone is resting on the surface. So that is why the distance will be the radius of the Earth, 6.37 times 10 to the power of 3. And kilometer, you have to change to meter, 10 to the power of 3. Or you times 1,000 and then just square it. So the value that you should get is, let me do it, 5.98 times 10 to the power 24 times 2.5 divided by 6.37 times 10 to the power of 6, you square it. And the value that I got was 24.6, 24.6 Newton. So 24.6 Newton. Of course, you can round it off to 25 because after all, you have to denote your final answer in terms of 2 to 3 significant figures only. I put it in terms of 3 significant figures. So I can accept 2 answers. One is 25 Newton, the other one is 24.6 Newton. Now, okay, let us switch to A-level EDEXCEL. This is the question. In January 2023, the asteroid 2023 BU came close to the Earth. The closest distance of the asteroid from the surface of the Earth was 3,590 kilometers. Calculate the force between the asteroid and the Earth at the closest distance. You may assume the asteroid is a sphere, right? So everything is given here. No worries. All we need to do is just to write down the equation that I am supposed to use to do my calculation, to perform my calculation. Look at the question again. The question asks me to find the force between asteroid and the Earth. Force between asteroid and the Earth, don't you think this is related to gravitational force? Right, gravitational force. Just write down the equation of gravitational force. Gravitational force is equal to gmm over r squared. I have the mass of the Earth, but I do not have the mass of the asteroid. Sad case right here. How do I find the mass of the asteroid? Don't worry. When the density of the asteroid is being given, just use this equation. Density is equal to mass over volume. But the volume is not given as well. Don't worry because they ask you to assume the asteroid as a sphere. All you need to do is just to recall a little bit of math here. What is the volume of the sphere? The volume of the sphere is 4 over 3 pi r cubed. So the r represents the radius of the asteroid, but they give you the diameter. So I need to find the radius. So the radius is equal to 5.65 divided by 2. So I use my value here, 5.65 divided by 2, and I get my radius, 2.83. I will put it as 2.83 right here. So the radius is 2.83 meter. Now I can perform my calculation. I just sub in the value. I make mass as a subject because after all, I need the mass of the asteroid. Mass of the asteroid is equal to density times the volume, 4 over 3 pi r cubed. Density is, asteroid is 1,950 times 4 over 3 pi. R is 2.83, but you have to keep it, remember? So I just keep it first. And times 4 over 3 times with pi. And I times 1,950. So I got 1.84 times 10 to the power of 5 kilogram. So this is the mass of the asteroid. Since I get that, so I just replace this 6.67 times 10 to the power negative 11. That is universal gravitational constant. Mass of the Earth is given as 5.98 times 10 to the power 24. And mass of the asteroid, so I'm going to sub in as 1.84 times 10 to the power of 5 divided by distance between the asteroid and the mass. So, okay, let me draw it here. This is the Earth. This is the asteroid. Okay, I just use a circle to represent asteroid. The question mentioned that the closest distance, right, of the asteroid and the surface here. This is the distance, 3,590 kilometer. And that is the radius of the Earth here, which is 6,380 kilometer. So if you want to find the R, remember what I told you about the R? R represents the distance from one mass to the other mass. So you have to add up all these. This will be your R. Beware with that. And you have to change the kilometer to meter. So I'm just going to put it as 3590 times 10 to the power of 3 plus 6380 times 10 to the power of 3 meter, and then you have to square it. Use your calculator and you should be able to get 7.39 times 10 to the power of 5 Newton. So that's the answer. So if you face any difficulties or you do not understand how I explain it, no worries. Feel free to comment below. Now, let us move to AQA, A-level physics, AQA. Now, one of the questions asks about the properties of the radial gravitational field. Here, right? This is what we call radial gravitational field. Go moving outwards like that. Okay. Sorry, inwards, yeah. Arrow must be pointing towards the mass because arrow inwards meaning to say that that's attractive, right? The two properties are, right? I would say that gravitational field itself, gravitational field obeys inverse square law, first one, and the gravitational force is always attractive and field lines are always pointing towards center of mass. These are the answer. And that's all for today. Thank you very much for watching. So remember that if you face any questions or if you face any doubts in any of the topics, right, that you want me to discuss on YouTube, feel free to comment below. So remember, lastly, gravity keeps the planet orbiting, star collapsing, and the black holes keep on growing, right? It is one of our fundamental forces, one of the 4 fundamental forces, and you are in its group every second. Do you want to dive deeper into A-level physics? Hit that subscribe button. Thank you very much. Bye.